Hello student, in this video we are going to learn about arithmetic instruction of 8085 microprocessor. At the end of the class you will be able to understand the various instruction under the arithmetic group. Let's start from arithmetic group. What is arithmetic group? Arithmetic groups include instructions that are used to perform arithmetic operations such as addition, subtraction, increment, decrement, content of the register or memory. Now consider add R. Add R. This instruction depicts about the addition of the content of register and the content of accumulator, and the result is stored in accumulator. Means in this instruction addition of the content of the register R and the content of the accumulator register R, content of the register R is added with the content of accumulator and result is stored in accumulator. Consider add B. B is the register and the data of the B is suppose 56 and the content of the accumulator is suppose 47. Now add these two content and the result is stored in accumulator. A is 47H. H indicates hexadecimal. 47 is in binary form 0 1 0 0. 7 is 0 1 1 1. Now B is 56H. 5 in binary form is 0 1 0 1. 6 is 0 1 1 0. Now add this to data. 1 0 is 1, 1 1 is 0, carry is 1, 1 1 is 0, plus 1 is 1 and carry is 1. 0 0 is 0 and carry 1 is 1. 0 1 is 1, 0 0 0, 1 1 0 and carry 1 is 1. This is 9. This is 13, means D. Here check the flag register. Sign flag is 1 because bit D7 is 1. 0 flag is 0 because result is other than 0. Now parity flag is 0 because odd number of ones is present in result. Auxiliary carry flag is 0 because in bit D3 the carry is generated and carry flag is set to 0 because in bit D7 there is no carry is generated. And M instruction. This instruction depicts about the addition of the content of memory and the content of accumulator, and result is stored in accumulator. The content of memory whose address is pointed by HL pair means the content of memory location addressed by HL pair is added with the content of accumulator, and result is stored in accumulator. Add the content of the memory location whose address is in HL pair and add with the content of accumulator, and result is stored in accumulator. Now ADC instruction. ADC R instruction depicts about the addition of the content of register, content of accumulator and carry status, and the result is stored in accumulator. Means content of register is added with the content of accumulator is added with the carry status, and result is stored in accumulator. Suppose A equal to 3F, ADC R means add ADC B. For example, then register B is A2 is added with the carry status, and carry status which is generated in previous operation. Suppose there is a carry status is 1, so this carry is added to this operation. 3F is in binary form is 0 0 1 1. F is 1 1 1 1. A is 10 means 1 0 1 0. 2 is 0 0 1 0, and now this one is 0 0 0 1. Now add this 2. One 0 1 and 1 0. Carry is 1 1 1 0 1 1 1 1 is 0 1 1 1 is 0 1 1 is 0. Carry is 1 1 1 0 1 1 1. This is 2, and the result is stored in accumulator A containing E2H. Here the sign flag is 1, 0 flag is 0 because result is other than 0. Parity flag is 3 1 because even number of ones is present. Auxiliary carry is 1 because in D3 carry is generated. carry flag is 0. Adc M Instruction. This instruction depicts about the addition of the content of memory location addressed by HL pair and the content of accumulator and carry status, and result is stored in accumulator. Content of memory is addressed by HL pair is added with the content of accumulator and the carry status, and ADI 8-bit data. ADI, consider an example, ADI 45H. ADI instruction depicts add immediate data with the content of accumulator and result stored in accumulator. Means data content of accumulator and result is stored in accumulator. Here data is given 45. Suppose A is content 39 and this result is stored in accumulator. A39, which is in binary form, is 0, 0, 1, 1, and 9 is 1, 0, 0, 1, and B is given here 45. H 0, 1, 0, 0. 5 is 0, 1, 0, 1, 1, 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0. This one is 7. This one is D. This 70 is stored in accumulator. Here the sign flag is 0. 0 flag is narrative flag is 1. Auxiliary carry is 0 and carry flag is also 0. ACI 8-bit data. ACI instruction depicts add immediate data with the content of accumulator and carry status, and the obtained result is stored in accumulator. ACI 8-bit data means data plus content of accumulator and which is generated in previous operation, and this carry is added with operation, and the result is stored in accumulator. Here data is given 45. Suppose 45 is added with the content of accumulator is 30, and suppose carry is generated in previous operation is 1. Now this result is stored in accumulator. First convert the 45 in binary form and 30 in binary form and 1, that is 0, 0, 0, 1. And this result, which is now DAD instruction. According to this instruction, HL pair is added with the another register pair and the obtained result is stored in HL pair. DAD, suppose consider an example DAD B. B is the BE register. In this instruction, content B register and the result is stored in HL pair. Suppose register pair B is pairing means 16-bit data 41 FFH hexadecimal, and register pair HL is 2020H. DAD instruction HL plus D and result stored in HL pair. After adding to this, the result is stored in HL pair. Sub instruction. Sub are the content of register is subtracted from the content of accumulator and the result is stored in accumulator. Content of the register are which is subtracted from the content of accumulator and result is stored in accumulator. Suppose content of accumulator is 37H and the content of SUB content of B is 40. Means in accumulator direct subtraction is not performed. That means A minus and result stored in accumulator. Means 37 plus of minus 40. That means find the 2s complements of minus 40 and this 2s complement is added with the 37 and result is stored in accumulator. A 37 and B is 40. A plus of 40. Write the 40 in binary form, that is 0 0 0 0 0 0. Its 1 is complement, that is 1 0 1 1 1 1 1 1. Now add 1 to this. 1 is complement. 1 1 is 0, carry 1 1 1 is 0, carry 1 1 1 is 0. Now 1 1 is 0. This carry 1 is 1 1 0 0 1 1 0. 1 1 0 1 1 0 and now this one is carry 1 is 1 and 1. This is the 2s complement of 40. Now this is added with the 47. Sorry, 37. 37 is in binary form is 0 0 1 1. 7 is 0 1 1 1 and 2s complement of 40 is 1 1 0 0. Now 0 0 0 0. Add this to data 1 1 1 0 1 1 1 1. This one is the F and this is 7. Carry is 0. Complement this carry, that is carry flag is 1. It means result is negative. Result is negative and it is expressed in its 2s complement in the accumulator. And what about the rest of the flag? Sign flag is 1 because bit D7 is 1. 0 flag is 0 because result is other than 0. Parity flag is 1 because even number of ones is present in result. Is 0 because in bit D3 there is no carry is generated and the carry flag is done, that is 1. Sbb instruction. In this instruction, content of the memory is subtracted from the content of accumulator and result is stored in accumulator. Content of memory location addressed by HL pair is subtracted from the content. Result is stored in accumulator. First you have to find the 2s complement of memory location content and this is added with the content of accumulator and result is stored in accumulator, means A plus of minus M and result is stored in accumulator. Now Sbb instruction. Consider Sbb instruction. The content of register and borrow are subtracted from accumulator. Suppose consider an example Sbb means content of register B register R is subtracted from the borrow is subtracted from the accumulator and result is stored in accumulator, means first you have to add borrow value into the register and this result is subtracted from the accumulator and final result is stored in accumulator. Let's see the example Sbb B. Once again accumulator, assuming that accumulator has having data 50 H. Register B added with the borrow and this result is subtracted with the accumulator and result stored in accumulator, means A is 50H and B is 3F. this B is added with the borrow. Suppose borrow is 1. 3F is in binary is 0, 0, 1, 1. F is 1, 1, 1. 0, 0, 0, 0, 0, 0, 1, 0. Means result is 40. Now A minus register plus borrow. This one is completed in this manner. Now find the 2's complement of 40, because in microprocessor 85 microprocessor subtraction is not directly done. So write here A of minus of 40. 2's complement of 40 is, first write the 40 is in binary form, that is 0, 1, 0, 0, 0, 0, 0, 0. Find 1's complement of this, that is 1, 1, 1, 1, 1, 0, 1. Add 1 to this data to find the 2's complement. Add 1. 1, 1 is 0, carry 1, 1, 1 is 0, carry 1, 1, 1 is 0, 0. Carry 1 is 1, 1, 0, carry 1 is 1, 1, 0, 1, 1. This is the 2's complement of 40. Now this one is added with the content of accumulator, that is 50. In binary form 50 is 0, 1, 0, 1, 0, 0, 0, 0. And 2's complement of 40 is 1, 1, 0, 0, 0, 0, 0, 0. Now add this two numbers 0, 0, 0, 0, 1, 0, 0, 0, 1. This is 0, this is 1. Now the accumulator, complement the carry flag is 0, sign flag is 0, carry is 0, or you can say borrow. Carry flag is 0, that means result is positive, means content of accumulator, that is 50, is greater than content of B, that is 3F. Sign flag 0, 0 flag is 1, auxiliary carry is 0, parity flag is 0, similarly in SM the content of memory and borrow are subtracted from the accumulator. Content of memory and borrow are subtracted from the content of accumulator and result is stored in accumulator. Means content of memory is added with the borrow, which is subtracted from the content of accumulator, and the result is stored in accumulator. Add the content of V with the borrow and find its 2's complement, and this is added with the accumulator content and result is stored in accumulator. SUI. Subtract the immediate data from the content of accumulator and result is stored in accumulator. For example, SUI 40H. Subtract the is subtracted with the content of accumulator and the result is stored. SBI 8-bit data. Subtract immediate data and borrow from the content of accumulator and result is stored in accumulator. Subtract the immediate data D and the borrow is subtracted from the content of accumulator and result is stored in accumulator. Consider an example SBI 45H. (45H) plus content of register B is and the result subtracted from the accumulator and the result is stored in accumulator, means A minus 45 plus of B and result is stored in accumulator. According to this instruction, the content of register R is incremented by 1 and the result is stored in register. Consider an example increment B, means content is added with the 1, means incremented by 1 and result is saved in same register, that is B. Suppose B is having number FFF after incremented by 1, the result is 00H. Similarly, in increment INR M, according to this instruction, the content of the memory is incremented by 1 and the result is stored in memory, means content of memory is incremented by 1 and result is stored in memory. INX R or INX RP. The content of register pair is incremented by 1 and the result is stored in register pair, means register pair is incremented by 1 and this result is stored in same register pair. For an example, INX H, means content of HL pair is incremented by 1 and result is stored in HL pair. Now DCR instruction. Consider DCR. The content 1 and the result is stored in register, means R is decremented by 1 and result is stored in R register. Consider example decrement B. Content of B is decremented by 1 and result is stored in same register. Suppose the value of B register is 00H. After the instruction DCR B, means D minus 1 and the result is stored in B and the result is stored in B register. In microprocessor, direct subtraction, so we have to find the 1s complement of this 1. 0 1, find this. 0 1 is in binary form is 0 0 0 0 0 0 0 1. Find the 2s complement. First we have to find 1s complement. 0 1 1 1 1 1 1 1. Now add 1. After adding 1, the result is FFH, and this FFH is added with the content of register B, and the result is to B register. Decrement M register. The content of memory is decremented by 1 and the result is stored in memory. The content of memory whose address by HL pair by 1 and the result is stored in memory. DCXR. The content of register pair is decremented by 1 and the result is stored in register pair. Means register pair is decremented by 1 and the result is stored in register pair. Consider an example. DCXH means DCXH decremented by 1 and result is stored in HL pair. There is one more instruction, that is DA. DA stands for Decimal Adjust Accumulator. The instruction DA is used after add, ADI, ACI, ADC, instruction, etc. After the execution of add, ADC, etc., the result is in hexadecimal and it is placed in the accumulator. The DA instruction operates on this result and gives the final result in decimal system. It uses carry and auxiliary carry for decimal adjustment. 6 is added to the 4 LSB of the content of the or the auxiliary carry flag is set to 1. Similarly, 6 is also added to 4 MSB of the content of the accumulator if their values lies in between A and F or the carry status flag is set to 1. Consider an example. Add the data 96 and 62. In binary form, 96 is 1 0 0 1 0. 62 6 0 1 1 0. 2 is 0 0 1 0. Now add these two number, that is 0 0 0 1. 1 1 is 0. This one is 1 1 0 1 1 1 0 1. In decimal addition, 4-bit MSB or LSB is greater than 9, then we have to add 6. This one is the 8, lies in between 8 to F, and this one is greater than, so we have to add 1. 1 0 is 1, 1 1 is 0, 1 is 1, 1 0 is 1, and carry 1 is 0, and this is 1, and this is same as 1 0 0 0. So the answer is, this is one is the 1, this is the 5, and this is the 8. Now answer is 158. In this case, we greater than 9, number is greater than 9, so we have to add 6. Here the instruction is used.